Hello, welcome to Windshine Audio. I'm Alvin, owner of Windshine Audio. Let's talk about the Denafrips Terra Master Clock. It is a master clock. It generates a various frequency output via the internal crystal oscillator. What is used inside oven control crystal oscillator? It is of premium quality and it ensures that the output clock frequency are of high quality. And what are the frequency that can output coming from this master clock is 45 MHz, 49 MHz, 22 MHz, and 25 MHz, as well as 44.1 and 48 kHz. It can be used hand in hand with the Hermes DDC, or the Iris DDC, or the Gaia DDC, or digital product that comes with external clock input that is compatible with the Terra Master Clock. So do not be confused with the 10 MHz master clock input that is found in some other product, because the Terra Master Clock cannot output 10 MHz clock frequency. So you need to be sure that the equipment that you plan to use with this Terra Master Clock can accept the clock output frequency of this master clock. Otherwise, the clock connection will not work and it is not compatible with the rest of the clock frequency, like 10 MHz, for example. 10 MHz is commonly found in studio recording environment, but Denafrips believe in native clock frequency for music. We know that 45 MHz is multiplier of 44.1, 49 MHz is multiplier of 48 kHz for that reason. Right, so product that can be used with this master clock that I have tested myself is, of course, the Denafrips DDC series, as well as the sound aware. Let me bring it up. Right, this guy is a sound aware streamer. It is a room ready endpoint. It's a pretty large unit, so I'm not putting it on top of my desk, but this guy can accept 22 and 24 MHz. So this 22 and 24 MHz output clock input frequency can be connected to this Terra Master Clock for clock synchronization between this streamer as well as the master clock. So I'll just leave it aside. Yeah, notice I made a mistake, so it's not 25 MHz, it's 24 point something MHz. Right, so these are the native music sampling rate frequency that derive from 44.1 or 48 kHz. Right, so once you've received the unit, please be sure that you switch the voltage switch at the back to the correct voltage before powering up. So if you are in the US, switch it to 115. If you are in the Europe, UK, or like me in Singapore, switch it to 240 before you use it, before you even power up this guy. Otherwise, the fuse inside will blow and you need to replace the fuse. I already have the top cover screw loosened. I thought of showing you what is inside before we zoom into operation. Right, open the top cover, put the top cover aside. Let me flip the unit. Alright. Slowly, don't damage the front panel. Okay, so we have a fuse here to protect the unit from malfunction, and we have a AC filter here that filters the AC noise, and a pretty large 80 VA auto transformer, a bunch of capacitor here for AC to DC power regulator. There are a bunch of Sockridge diode here that converts the AC to DC. It goes through a series of reservoir caps to reduce the ripple. Thereafter, it goes through super regulator here to convert the DC voltage to a precision and high current DC voltage before sending it to these two it's OCXO. It's oven control crystal oscillator. It is of higher grade compared to the TCSO or other crystal oscillator on the market. It is oven control. It runs pretty hot. It is keeping the same temperature throughout the operation, so that the output frequency of the two OCXO here stay pretty constant throughout the same temperature. Right, we have a FPGA here that handle the change of different frequency. There are some setting here that you can do to change the output frequency of the OCXO to 22, 24 MHz or 44.1 or 48 kilohertz. Right. There are some other components here for power regulation. This is Denafrips signature, multiple capacitor to lower the EXR effect. Right, that's about it for internal. And let me flip over to the back to show you the back. Okay. Okay, a power inlet here that allow you to connect the IEC power connector, and a bunch of BNC output connector here that has certain frequency fixed at 45 megahertz and 49 megahertz. So this 45 and 49 megahertz has got the output frequency always on that you can connect to Hermes DDC, Iris DDC, or Gaia DDC, and we have connection of master clock 1, 2, 3, 4 here. These are the adjustable output frequency connector that you can make use of the front panel to adjust the output frequency of the master clock 1, 2, 3, 4 here to suit the connected device. For example, for the sound aware that I have on the floor, I set 22 and 24 megahertz. So I can make use of the front panel to control to change the output frequency of the master clock 1, 2, 3, 4 to 22 and 24 megahertz to synchronize the clock of the Terra and the sound aware streamer. So sound aware streamer D300 and D300 reference comes with external clock input that can be connected to this Terra master clock. Right, let me flip it to the front and power up this guy to show you some of the simple operation. It's pretty simple, so there's no complex setting. Just power on this guy using a simple power cord that I have here. Plug it in. So once you plug in, there's no power switch. It will turn on right away, and we can see that there are a couple of LED lights up here and there are a couple of LED lights up here. So 45 and 49 megahertz LED light up here, it tells us that the 45 and 49 megahertz are being output via the BNC connector at the back. And we have group 1 and group 2 configuration here that allow us to set the output frequency. So you need to refer to the manual to tell what are the settings that you need to set for certain output frequency. But I'll just show you some of the simple operation on how to configure this guy in a video form. Right, press on the setup button once. So once the setup button is pressed, it goes into configuration mode, and press on the group 1 LED or group 1 button multiple times, and this group 1 button changes the output frequency of the group 1, of course. And if you press on the group 2, it changes the output frequency of group 2. So please refer to the manual on which selection is correspond to a certain frequency output adjustment, and so that it can be used with the external device that you are connecting to this master clock. One of the most frequently asked questions of this master clock is that what it does. Does it convert anything? No, it doesn't. It is generating output frequency, clock frequency, and it has to be used hand in hand with a streamer, a DAC, or a DDC, basically the digital product, the digital conversion product that is compatible with this master clock. It doesn't do digital to analog conversion. It doesn't do digital to digital conversion. It is just a master clock that generates clock output frequency. Alright, so once the setting is confirmed, just press on the setup button once to confirm it, and it will be stored in the memory itself, and the next power up, the memory will be retrieved and it will be using the same setting again. So how do we connect this to the Hermes DDC? I need to power off this guy, both of them, and lift the two guy up. I hope I can do it. Yes, I can. Right. So you need to use 75 ohms BNC cable to connect the BNC output of the master clock to the BNC input of the DDC. I have Sommer cable here, a studio grade cable from Sommer Cable, 75 ohms BNC connector, and comes in two color. So we can differentiate the color of 45 megahertz and 49 megahertz respectively. So I'll use the blue color one to connect the 45 megahertz from the Terra master clock to the 45 megahertz of the Hermes DDC. So BNC connector, you need to plug it in and do a twist to lock the connector. So plug in, twist it to lock it. Right, and plug in, twist it to lock it. So the connection wise will be like this, and of course the Hermes DDC need to be configured to accept external clock. So just flip it over and we will do the setting, and we'll show it to you how to do the setting to allow the DDC to accept an external clock input. Power on the Terra, and where's my power cord? Power on the Hermes DDC. Hermes DDC takes a while to start up, so about a couple of seconds. Once it is start up, the last used LED will turn on. The last used digital input LED will turn on. So how do we configure this Hermes DDC to accept external clock input? Press on the setup button once. So once the setup is engaged in configuration mode, the setup LED on, and press on the, you also notice that the coaxial LED turn on and off. So press on the optical, let me change hand. Press on the optical button a few times to toggle the clock LED turn on and off. Leave the LED on so that the Hermes DDC will use the external clock input from the Terra Master Clock. If you do not have a Master Clock, turn off the clock LED. So I'll repeat this again. Right, press on the setup button once. Once it is in configuration mode, the coaxial LED start blinking. Press on the optical button and toggle it to turn on the clock input. The LED on means that the Hermes DDC is expecting external clock input. Once it's confirmed, press on the setup button once. That's about it. So Hermes DDC is configured to accept the master clock output from the Terra, and the clock in the Hermes DDC will bypass, and the clock will be referenced to this master clock. That's about it. Thank you so much for watching. See you next time.